Welcome to example 2.8. Example 2.8. It says the three-phase 4-wire 50 Hz system. Three-phase 4-wire 60 Hz system. So that is three-phase. That is one phase. 1, 2, 3, 4. So A, B, C, and neutral. Then we have a three-phase impedance connected in star. So three-phase impedance connected in star, and with a impedance 11.5 plus J4.5. So star, that means you have a star connected system. A star connected load. This is a star connected load that is connected to the line. So if this is line A, B, C, so A will be connected straight to A. B will be connected straight to B. And C will be connected straight to C. That is how that load is connected. Then we look at the second load, which is a delta connected load. A delta connected load, that is a delta connected load. This is a delta connected load. So it's now connected to those three lines also. This is A, B, C. So A is connected to A, B is connected to B, and C is connected to C. Right. So we have impedances ZAB, ZBC, and ZCA. So ZAB, ZBC, and ZCA. Right. Then we now have another load, a single phase load of 5.8 between C and the neutral. Between C and the neutral. There's a load between C. This is the load that we're talking about. Between C, starting from C, between C and the neutral. So that means it comes, the load, the line comes into the load, C, then it flows back into neutral. So that is the third load. Then we now have another load, which is the fourth load, a single phase load of 5 between B and C. This one is also between B and C. This another load between B and C. This is B. So it comes between B and it flows back to C. So that is another load. So now we can, that one is also 5 at angle 36. 5 at angle 36 degrees impedance ohms. Then the other one is 5.8 at 60. 5.8 at angle 60 degrees ohms. Then, of course, you can see the load of the star and the load. Now we are asked to draw the equivalent, the correspondent circuit. This is the correspondent circuit that we have just drawn. That is for 2.8.1. Now they say take VB as your reference. VB as a reference. So we want to draw the phasor diagram. VB is our reference. And the VB is at what angle? They say VB is at 1220 at angle minus 30. So at minus 30. So you have to draw minus 30. So this is VB at angle minus 30 degrees. Let's look at the rotation. Direction of rotation is what? We said we have it at positive phase sequence. So positive phase sequence. So if it is positive phase sequence, that means 120 degrees from this one will give you where our VA is. What is 120 degrees from here? That means you are going to have your VA VA at angle 90 degrees. Right. That is between VA and VB must be 120. Then you now have what? You now have VC. From here, if this VB plus 120, that takes you to VC. So VA, VB, VC, this will be at angle minus 150 degrees. So those are the phase voltages represented on the phasor. Because it is positive phase sequence, so this it will automatically be what? VBC, because it must be 30 degrees from this. The line will lead by 30 degrees. And this also 30 degrees will be VAB at angle 120 degrees. That is 30 degrees between the, and we now have also what VC, this is VCB, sorry, I mean VCA at angle minus 120 degrees. Right. That is the phasor diagram as we have for this particular circuit. Then with that, now we are asked to calculate the current flowing in line C. What is the current flowing in line C? Current flowing in line C, IC, is the current flowing in line C. So that current flowing in line C is flowing into this load this way. Is the same current from line C coming into this load. Is the same current flowing from line C into this load, line C. And when you come here, you see that current in line C, this one is flowing back into line C. It's flowing back to line C here. So that means you need to get your IC. You can call this one IC1. You can call this IC2. You can call this IC3. And this one will be IC4 because it's going to IC. So that means we need to find our IC1. Our IC1 will be what? Our IC1 will be, because this is the current flowing into this phase. So it will be VC, this is supposed to be N, right? It will be VCN divided by ZC. This is ZA, this is ZB. So to get your IC1, you want to, actually what you want to do is you want to get all these IC together and add it together to give you the current IC. So our IC1 will now be what? Will now be VC, the voltage across this divided by ZC. That's VC divided by ZC. So what is our voltage VC? Our VC from the phasor diagram is at angle minus 150 degrees. And what is VC? The voltage given to us, which is 220 volt. They gave us VB, which is phase voltage. So, and VC is also phase voltage. So 220 at angle minus 150 divided by ZC. What is our ZC? Our ZC is given as 1.5 plus J 4.5. That is the voltage. That's the impedances in those the load in the star connected system, which appears to be balanced because we have the same load in them. So that one gives you what? That one gives you IC1 at 17.815 at angle what? At angle minus 171.37 degrees amps. So that is IC1. So we need to find IC2 now. IC2 will be when you look at this, you see at this point, you see that ICA is going through and IBC is also coming to this point, and IC2 is coming here. So you take, using Kirchhoff's current law, you want to find the total, the summation of the current around that particular node. So IC2 is taken as going in, IBC takes also positive, take it as going in, ICA take it as going away. The summation must be equal to 0 according to Kirchhoff's law. So our IC2 is equal to what? ICA minus IBC. So we now have to find our ICA. ICA, which is the current flowing inside this phase, will be the voltage across here, which is the phase voltage, divided by the impedance. So that means it is VCA, the voltage across here, VCA, divided by the impedance, ZCA, minus IBC, the current flowing through here, which is VBC, divided by ZBC. So what is our VCA? VCA, it is phase voltage here, but it's equal to line voltage from the supply, because it is between C and A and C, which is line voltage there. So you have to find what is our VCA, which is line voltage, and you are given phase voltage as in your question. So you have to find your VCA to take it to the line. So that means you multiply by √3. √3 multiplied by your phase voltage at angle what? At angle VCA. VCA is given as minus 120 degrees. That's minus 120 degrees. Right. Then minus, you now have to find VBC. What is our VBC? Our VBC is at what angle? Our VBC, if you look at it, our VBC is at angle 0 degree. So that means minus VBC, which is also √3 times 220 at angle 0 degrees. Right. Divided by our also ZBC. This, let's not forget that we divide them. Let me write it out here. Our VCA, which is √3 times 220 at angle minus 150 degrees, divided by, minus 120 degrees, divided by ZCA minus √3 into 220 at angle 0 degree, divided by ZBC. So when you sort this out, that will give you your IC. So this will give you our IC. Right. Which is IC2. Sorry, IC2. Because IC2 that's got it. So that will give you your IC2. So you get your IC2. Now you look for your IC3. Our IC3 is equal to the voltage across these two, the voltage across, which is VCN. So IC3 is VCN divided by Z. Let's call this one Z3. And this one we call it, let's call it Z4. So that means that will be divided by Z3. So that gives you, what's your VCN? Your VCN is at angle minus 150. That is 220 at angle minus 150 degrees divided by Z3, which is 5.8 at angle 60 degrees. So that will give you your IC3. Then you come to find IC4. IC4 is going to be the voltage between B and C. So our IC4 will be VBC divided by Z4. So our VBC is 220 at angle 0 degree times √3, because it is line. Then divided by Z4, which is our Z4 is given as 5.5 at angle 36 degrees. So you use that to get your IC4 also. Once you get IC4, you can get IC, because our question says you should calculate the current flowing in line C. And flowing in line C will be what? It will IC, which is that line current line C will be equal to what? If you take this node, for example, take a node like this. This current is flowing into IC. IC is taken as positive. Then this one is flowing away. minus IC1 is flowing away. IC2 is flowing away minus IC2 is flowing away from that node. IC3 minus IC3 is flowing away from that node. But IC4 is flowing back into that node plus IC4. So everything will be equal to 0. Right. So now all you need to do is our IC then will be equal to what? Our IC will then be equal to what? IC1 plus IC2 plus IC3 minus IC4. So that is going to give you our IC. IC is equal to IC1 plus IC2 plus IC3 minus IC4. And that will give you, so you just substitute those values and you get what your IC is. Then the next question says you should calculate the current flowing in the neutral conductor. Current flowing in the neutral conductor is this. This is the only current flowing in the neutral conductor, the current flowing back here, which is IC3 negative. That is flowing back. If you look at it, this is the current. This IC3 is flowing back here. It's flowing from from C. Then is the one flowing back into the neutral conductor. So that is the current IN is equal to minus IC3. So you have your IC3 that you have calculated. You find it and you get your IN. Thank you.